Section 2.4 is three-dimensional shapes. Our objectives for the three-dimensional shapes section is that we'll name and draw three-dimensional shapes. First definition is polyhedron, or the plural of that is polyhedra, and it is a three-dimensional shape composed of polygonal regions, any two of which have at most a common side It is connected. It is an enclosed, connected, finite portion of space without holes. If I were to draw a picture of a polyhedron, it would look like if I did a rectangular prism. We'd have a face that's a rectangle, and then you make these. I didn't do a very good job of it, but the lines in the back should be dotted because you would not see those if the shape were solid. So one of the sides is a face. Where the faces meet is an edge. And where the edges meet, they meet at a vertex. Another example of a polyhedron could be some type of pyramid. That's a pyramid made out of triangles. A quiz question might be, where do the faces meet? Okay, the faces meet at an edge. Where do the edges meet? The edges meet at a vertex. The faces don't meet at a vertex. That's a common error, okay? The faces meet at edges. Prism. A prism is a polyhedron with two opposite faces that are identical polygonal regions in parallel planes called bases. The other faces are called lateral faces. The height of a prism is the perpendicular distance between the bases. They are named by the shape of their bases. Examples. This is a rectangular prism. the top and the bottom are rectangles. So based on that, we can call it the rectangular prism. The sides that aren't the bases are called the lateral face. This is a lateral face. Triangular bases. It's a triangular prism. If it has hexagonal bases, it's a hexagonal prism. Let's look at 3D figures of these. So this you could call this a rectangular prism or a square prism because the bases are squares, depending on what you call the bases. This is a triangular prism. Now the bases don't have to be the top and the bottom. This could be sitting like this. It is still a triangular prism because the definition of the bases is congruent shapes that are parallel to each other. These rectangles are congruent. They're the same size, but they're not parallel. So the parallel sides are the triangles, which are congruent. So that would be a triangular prism. This is what a hexagonal prism would look like. The bases are hexagons, the sides are rectangles. Right prisms are prisms whose lateral faces are rectangular regions. Otherwise, they're called oblique prisms. All the examples in the solids I just showed you are those are right prisms. The sides were rectangles. An oblique prism might look like something like that. The sides are not rectangles, they're parallelograms. Pyramid. A pyramid is a polyhedron consisting of a polygonal region for its base and triangular regions as lateral faces, which all meet at a point called the apex of the pyramid. The height of a pyramid is the perpendicular distance from the apex to the base of the pyramid. A pyramid is named by the shape of its base. So examples of pyramids. We've got, this is a equilateral triangular pyramid because the base is an equilateral triangle. you can see that the apex is a point where the edges of the sides meet. The height of the pyramid is the perpendicular distance from the apex to the base. Don't get that confused with slant height. Slant height of a pyramid is the height of the one of the triangles on the side. The slant height is going to be greater than the height of the pyramid. But you have to know the difference, because when you figure volume of a pyramid, you want to use the height, not the slant height. So make sure you're aware of that. Square pyramid. The base is a square. This is a hexagonal pyramid. This pyramid is oblique. The apex is not directly over the center of the base. So it's an oblique hexagonal pyramid. Questions? Okay, regular, polyhedron. A regular polyhedron is a polyhedron in which all faces are regular polygons of exactly the same size and shape. There's a limited number of these. On page 78 in the book, they show the 5 regular polyhedron. You've got a tetrahedron. It's made of triangles. A cube made of squares. There's an octahedron, 8-sided, made of triangles. An icosahedron, that's 20 sides, it's made of triangles. And a dodecahedron is 12 sides, it's made of pentagons. Those are the only 5 regular polyhedron. None other combinations of shapes will fit together without there being gaps or spaces. So those are the 5. Tetrahedron. A tetrahedron is a regular polyhedron with 4 sides. It says, why is a soccer ball not a regular polyhedron? Why? Any soccer players in here? Why isn't a soccer ball a regular polyhedron? Are all the faces the same on a soccer ball? Okay, there's pentagons and hexagons. The black faces are regular pentagons. white faces are regular hexagon. Circular cylinder. A circular cylinder has circles as the base and the sides are circular. So we've got the base. Okay, this makes a right angle with the side makes a right angle with the base, so this would be a right circular cylinder. Then we've got a circular cone. Its apex is not directly over the center of the base, so this would be an oblique circular cone. This is the height. It's oblique. Sphere. The set of all points a fixed distance from a given point. That given point is called the center of the sphere. So a circle, the difference between the definition of a circle and a sphere is a circle would be all the points in a plane equidistant from a given point. In a sphere, it's all the points in space equidistant from a given point. Radius is a line segment whose endpoints are the center and a point on the sphere. A diameter is a line segment that contains the center of the sphere and endpoints are on the sphere. So we have here, if I draw a sphere, there's a sphere. There's the center of the sphere. From the center of the sphere to the side of it is a radius. And the connecting 2 points on the sphere that goes through the center is the diameter. Any questions on the notes? No questions on the notes. All right.